We can see that as a result of body force generation, the particulate, having a density lower than the fluid, migrates towards the center. As we enter bidirectional rotation, the REVROT mode, we can see that these particles now disperse. Since there is no longer rotational flow as that which exists with unidirectional mode, body forces do not exist responsible for the transport of these particles to a central point under the rotating impeller. In this next sequence, a much higher rotational velocity was used to demonstrate the effect of vortex formation on the surface. Particles were once again added that form a supernate because of their low density. In the case of unidirectional rotation, clearly a free surface vortex can be seen, and ingestion of the particles under the metal surface, or in this case, liquid surface, is evident. In transitioning to REVROT mode, a rapid cessation of vorticity occurs and a dispersal of the particles on the surface, indicating the avoidance of particle ingestion. Moving on to review of actual performance data, we'll first consider the case of hydrogen removal. In this situation, the alloy was 6111, operating at a metal flow rate of 60,000 pounds an hour that produced a per-stage metal residence time of 96 seconds. 2 stages were used, and the process gas consisted of 150 SCFH argon per stage. All hydrogen measurements were made through solid extraction. In the first situation, it can be seen that an incoming concentration of 0.203 cc's per 100 grams hydrogen was reduced in the first stage alone to 0.082 cc's per 100 grams. That is a 60% reduction. The overall reduction of hydrogen across both stages was 82%, a very impressive 82%. Importantly, it can be seen that the outlet concentration of hydrogen was 0.037 cc's per 100 grams of aluminum, an exceedingly low value. The other samples depict similar performance. In the next situation, we will evaluate REVROT performance in trace element reduction. We were using 5052 alloy at a metal flow rate of 61,000 pounds an hour. That results in a per-stage residence time of only 94 seconds. I need to note that this is significantly lower than a metal residence time requirements of competitive processes. The process gas used was 150 SCFH argon per stage at 3.7 standard cubic feet per hour chlorine per stage. Sodium concentration was 8 parts per million at the inlet and reduced to 2 parts per million at the outlet of the 2-stage unit. Similarly, calcium and lithium reductions are illustrated. The important consideration is that although the stoichiometric requirement for this level of trace element reduction combined with 7.3 standard cubic feet per hour, we only use 7.5 standard cubic feet per hour that resulted in 97% stoichiometric reduction. A very significant consequence of this is a substantially reduced generation of intermediate reaction products such as magnesium chloride. Magnesium chloride is highly detrimental not only for the longevity of metal treatment systems, but also as a significant detractor of metal quality. Given the information that you've just been exposed to, you can see why we're quite excited about REVROT. REVROT is a commercially successful process. We have units operating in the foundry industry in batch processing mode, units operating in the rod alloy arena as both a complete system and as retrofit drives for existing flexing systems. The metallurgical performance of REVROT is quite stellar. We consistently achieve in excess of 90% stoichiometric reduction, in some cases 95%, and in even other cases as high as 97% stoichiometric reduction. The obvious ramification of this is greatly reduced chlorine consumption and the commensurate reduction in emissions as a result. Hydrogen removal is also excellent. Typically, we operate in the 75% plus conversion efficiency, and we've even recorded levels of as low as 0.035 cc's of hydrogen per 100 grams of aluminum at the outlet of a REVROT process. And inclusion flotation, the third objective of inline metal treatment, is also extraordinary. This enables downstream filters to be operated longer and with higher levels of efficiency. Now, this is all achieved at a remarkably simple mechanical package. Even though the underlying principles governing REVROT operation are rather complicated, those principles have been reduced to practice in a highly efficient and compact manner. The drive is hydraulic. It is constructed of 7 different alloys, many of which are corrosion resistant. The unit is exceptionally small, weighing some 67 pounds for a 5-horsepower unit, easily maintained, easily transported, which is a distinctive feature over other competitive systems. This can all be integrated into a complete fluxing system that also contains proprietary apogee heating and control technology. Again, we're quite proud of REVROT and its performance. I hope that you'll choose REVROT, and if you have any additional questions, please contact your sales representative. Thank you very much for your attention.